Everyone. In this video, we're going to talk about a statistics primer with R and review of functions. So statistics is going to be the focus in part of this week. And so I want to take a minute, a set of slides that'll go back and go through some of the material that I sort of assume that you know, because technically stats is a prereq for this course. And so I'm gonna go through I guess probably too fast for some of you and too slow for some of you on some of what I think is really important, what parts of statistics are really important in data science. Now, in my opinion, it's everything. In others' opinions, it's not everything, maybe even almost nothing. And so there are varying views, but I am a statistician, and so of course I am sort of biased into liking stats and thinking that it's important, even in data science. But anyway, I digress. We're going to talk about a stats primer with R, and we're going to do some function stuff within it. And so what we'll talk about are what I view as the basics of statistics, as I said before, that's sort of pointed towards what we're doing in data science. We haven't really done a lot yet that would be considered traditional like statistical inference, but we have done a lot of EDA, of what I called EDA, and that's a very important part of the statistical routine or of doing a data analysis, whether you're a data scientist or a statistician. So we have done some statistics and we have thought about it, but just not overtly. And so what we're going to talk about are descriptive measures, randomness, and I'm missing an S there in randomness, sorry, probability distributions, and then inference. Okay, and then we're going to look forward, and what we're going to see in subsequent videos and slides are regression and modeling. And I've mentioned those things before, or you've probably heard of those words before, and we're going to talk about them a little bit more in depth. So these are, well, some basic statistics slides that are from my intro statistics courses. And so I think we want to define some terms first before we use them. And so I define data, statistics, and then the statistical, but really also it's also the data science process. So data is the information that we gather from experiments and surveys. It's the pieces of stuff that we have. Statistics is the art and science of learning from data. That was the name of a book that I had used before that this pseudo definition came from. But technically a statistic is any summary of data, and the statistics is the study of those summaries. Okay, you've done a lot of summaries, especially with the dplyr stuff, and so you've worked with statistics before. And so the process that I have down here, this 4-step process, is, well, we've sort of been doing definitely part two and maybe the beginning of part 3, but formulate a question, collect data to answer that question, analyze the data, and then interpret the results. I think you really, as a data scientist, don't often formulate the question, and sometimes you collect data and sometimes you don't, but you probably aren't sending out a survey or actually physically out there collecting data. You might scrape data from places, so on and so forth. And so it might seem like probably questions or parts 1 and 2 of the process aren't really important, but for a data scientist or a statistician, sorry for my little bit of a rant here, but those steps 1 and 2 are really important in 3 and 4, because you have to formulate a correct question and also collect data that answers that question. I think as a data scientist, and definitely as a statistician, when you're working for somebody, you as a data scientist are going to be working at a company, and someone else is going to have a question that they need answered with data. The same with a statistician. And they might already have, so they definitely have the question. They might also have the data, But what you need to pay special attention to when you run a routine, when you build a model, when you do whatever comes next after this, after Data Science 1, after what we're talking about right now, the important question is, the first question is maybe, can you do it physically? Can you run the function? Can you run the code? Can you do that? Can you make whatever you want to make? And that's a good thing if it does run, but it doesn't mean it's right. The more important question is, should you have done that? Can you really say what you want to say about the data with what you're doing? That's a part that people often skip over, but it's the really important part of what separates, a bad from a good data scientist, a bad from a good statistician. Okay, anyway, so I'll stop digressing and we'll talk about summary. So there are two types of statistics, descriptive and inferential. So descriptive is what we've been doing so far. Inferential is, what we'll get to a little bit later on. So descriptive measures in Stats 1 or whatever stats that you've taken before, you've hopefully learned about a bunch of summary statistics, mean, median, so on and so forth. Okay, R, because it is made by statisticians for statisticians originally, is going to have nice built-in features for these descriptive statistics. And so you've used this before in homework, but for measures of center, so looking at a center of data, a center of a distribution, you use mean, so there's mean, median. There is no default mode, so there's not a mode function, but the measures of center, mean and median, spread, standard deviation, variance, range, IQR, and for the life of me, I always forget when I write these slides what MAD is, because there's multiple things that could mean that. So if you're interested, you could look that up. I forget. Certainly I looked it up and I put it on here for a reason, but I forget what it is at the moment. And then percentiles is the quantile function. So I have a little challenge for you now, or your turn. Even though there's a built-in IQR function, I want you to try to make your own. And so I've started it here. I created a template IQR function. And so as a refresher, I didn't tell you what the IQR was, but the IQR is quartile 3. So generally, the IQR is Q3 minus Q1, where Q3 means the third quartile, and Q1 means the first quartile. Those are the points. So quartiles are slashes in the data, you separating the data at certain parts, such that you separate the data into quarters, hence quartiles. So, but people often forget about quartiles, Q1, Q2, Q3. You might be able to say them, but what do they mean? Another way, a way that more people will get it, is that the third quartile is the 75th percentile, and the first quartile is the 25th percentile. Okay. Now I gave you a function in the last slide to calculate percentiles, and so it's the 75th minus the 25th percentile. So if you want to stop the video and try to make your IQR function and then check it, I have some code down there, and you can run that to check if you got it. Okay, now on to randomness. Randomness is key to statistics. What makes statistics different from mathematics, I guess that's a separate conversation if you want to have. Stats is not math. We'll say, at least my view is that statistics is its own field that uses math to do what it wants to do, in the same way that physics is a field that uses a lot of math, but you just wouldn't call part of math. Now, there are plenty of people out there who think statistics is just another type of math, that it is just applied math. There's lots of different views out there, and we don't need to get into it. But anyway, randomness is key to statistics, what stats is trying to do, and it's what separates stats from math. So important in defining randomness is what's called a random variable. It's a numeric variable whose outcome is not known until after the event happens. So I have a simple example to try to get us in the mindset. So the situation is I flip a fair coin 10 times. So I've got a coin, it has two sides, it is fair, which you can interpret as meaning there's a 50% chance that you flip it and it lands heads. There's a 50% chance that you flip it and it lands tails. Okay, so that's the situation. The random variable is counting the number of heads out of 10 flips. So you flip the coin 10 times, you count the number of heads. Okay, that is the random variable. Okay, and so it's theoretically the number of heads out of 10 flips. Now, before I flip the coin 10 times, do I know what happens? No. And so hence that's why the variable is called random, because I don't know what's going to happen until it happens. Okay. That's the mechanism that we need to use to start randomness. And then the next thing that we do in the stats class is that we say that that random variable behaves a certain way. Okay, so if I counted the number of heads out of 10 flips, those numbers, every time I flip a coin, every time I do my 10 flips, the outcome is not going to be the same. Sometimes I might get 5, sometimes I might get 7, sometimes I might get 3. I could even get 1 or 0 or maybe 9 or 10. They are all possible, but they're all not equally likely. And so there's some behavior there. So you would say, what's most likely? And I think everyone would agree that 5 heads out of 10 flips is most likely, but it's not always going to happen. And so that behavior is important, and we need to characterize that behavior. And so that's what I'm saying here. Okay. And so that's what we are going to do with something called a probability distribution. Okay, and so I have another your turn. So I want you to make a function that simulates flipping a fair coin for a specified number of times. So this is, again, more function use, because in the assignments that I'm going to give you for this week, you're going to need to do some functioning. So using some functions. And so I think this is helping you, or hopefully. I put this in because I want this to help you, I should say. Okay, so I want you to make a function that flips a coin a specified number of times. Okay, so I give you a hint. The key function that you want to use is sample. So look up sample and then try to make a function that outputs 10. Well, you have to figure out what you want to label each side of the coin. Do you want to use H and T, 0 or 1, so on and so forth? You make that choice, and then your function should output 10 of, well, 0s and 1s, or H's and T's, so on and so forth. And I'm actually going to stop this video here to try to make my videos a little bit shorter. And so we're going to come back next time and continue on with this stats primer.